Minasan, konnichiwa, Zamurai Engineer desu. In this video, let us go to the next chapter, which is chapter number 4, and it deals with simultaneous linear equations. So we are going to use the numerical solution in order to solve simultaneous linear equations. And this is the first method we're going to use, what we call Gaussian method. So let us take a look. We have the name Gaussian elimination. So this is the basic type of Gaussian elimination. So on the first introduction of this method, this is the form, the procedure that it takes. And up to now, there are several modifications by several mathematician authors. This naive Gaussian elimination, which refers to the basic one, is a method to solve simultaneous linear equation of the form. A is a matrix, so a square matrix. X is a vector, is equal to some constant value of vector. So X is a variable, A are the elements of the coefficient of the equation, the coefficient of the variable X. So X the variable, so there are several X's, X1, X2, X3, so on, and is equal to, if you multiply matrix times X, as we know in mathematics, in advanced engineering math, it is just equal to some value or constant, which is a vector. Okay. So by now, I would assume that you already know what we are talking about when we say vector and matrix. So if you don't know what is a vector and what is a matrix, you have to review back the previous mathematics. The use of a vector here is somewhat actually the same with the physics vector scalar quantity, but it is a format, not the physical characteristic. Actually, it has the same related meaning, but this is a vector quantity wherein it has a magnitude and direction, but not in that sense, but in the sense of formation of the elements involved in the arrangement of the values. So there are two steps in this process. Number one, forward elimination, and number two, back substitution. So when we would perform forward elimination, this is just we are going to actually to simplify the whole system of simultaneous linear equation. Simplify, and what we mean by backward substitutions, now we are now doing the procedure where we are one by one. After simplification, we are one by one determining scientifically with the step by step. Okay, we can do it deterministically. We are going to find out all of the values wherein the variable is equal to. Okay, so let us proceed. Forward elimination is the first step in this process, and the goal for forward elimination is to transform the coefficient matrix into an upper triangular matrix. That is our target. So our target in doing this, making this matrix a triangular matrix. Not just triangular, but for simplicity and uniformity of solution of the procedure, we are choosing upper triangular matrix. If you don't know what is an upper triangular matrix, you have to review previous mathematics. And actually, this is just the matrix, which is 3 by 3 on this left-hand side. So on this left-hand side, we have the matrix A times vector x is equal to vector constant values. So these are the variables: vector x, x1, x2, x3. So there are 3 variables. There are 3 unknown, x1, x2, x3, and 3 equations. 1, 2, and 3 equations. And these are the coefficients. Okay. So meaning to say, the first equation is 25x1, 5x2, and 1x3 is equal to 106.8. And the third equation, as a review, is 144x1 plus 12x2 plus 1x3 is equal to 279.2. So this is how we are able to gather the simultaneous linear equation into a very compact. We cannot say it is better right now because there are only 3 equations, but if you have 5 equations, 6 equations, this type of representation becomes necessarily helpful. Okay? So what we are going to do is to make it this is the given equation, which we just want written down in the matrix format, and then forward elimination make this matrix is equal to be equal to this. Make this matrix to be like this matrix. What do you mean by this matrix? Upper triangular matrix. This is a triangle, this one. This is triangle. Why? Because the lower triangle here is a smaller one and also composed of elements which are equal to 0. That's why it is called upper triangular matrix. So we are looking at the upper portion and triangle in shape, which is inside this matrix. Okay? So doing a procedure that will make this simultaneous linear equation into this one. If you try to do this, the constant values will change, as you can see here. Okay? The first equation will not change the constant value because the first equation will retain, because we did not do anything about the first equation, because in transforming it to triangular matrix, only the second equation, the third equation, and so on would change. Okay? That's why the first equation did not change here. 25 by 1, 25 by 1, and 106.8. However, because we manipulated mathematically the second and third equation, also the constant part of those would change, not only the matrix coefficient part. Okay, so again, that is the goal. And how can we do it exactly, step by step? Okay, a set of n equations and n unknowns, and that example, that is 3 equations, 3 unknowns. So 4 equations, 4 unknowns, 5 equations, 5 unknowns. So those are the types of simultaneous linear equation that looks like this: one variable, another variable, and so on, up to the n variable. There are n variables. If there are 3 variables, it could be x, y, z, or it could be a, b, c. But usually we use a, b, c as to represent constant coefficients, and we use x, y, z usually to represent variable. Okay? So let have n minus 1 steps of forward evaluation if we have n. Why? Because we retain the first equation, just like we observed in the previous. So in the previous example, we have what? Equation 3 unknowns, and we have what? How many steps? 2 steps. 3 minus 1 is 2 steps. So that's why we did not do anything about the first equation. This is the necessary procedure. Okay, now, if we are going to do it by using our step-by-step process, for step 1, equation 2, consider divide equation 1 by a sub 11 and multiply by a sub 21. Ignore, a sub 11 is the coefficient of the first variable in equation 1. Okay. Okay. So in equation 1, here, for example, here, okay. Okay. This is equation 1. We have to manipulate equation 1. Okay. By dividing it by A11, A sub 11. Actually, this is A sub 11 because we do not actually change the first equation, but we are going to divide it, okay, by A11. So divide equation 1 by A11. So this one, A11. A11 is equal to the first coefficient of the first variable of the first equation. The first coefficient of the first variable of the first equation. This is the first equation, this is the first variable, and the first coefficient. Okay? So divide any coefficient there, divide equation 1 by that amount and multiply by A21. What is A21? A21 is the coefficient of the second equation, where the first coefficient of the first variable of the second equation. So that is the what? The A21. Okay. So actually, as you can review, this is not 11 but 1 1 because it states that this is row and column. Row, column. Row, column. First row, third column. First row and column. Okay. So that is the subscript of the coefficient, of the constant coefficient. So first row, first column. Second row, first column. So this is a what? Constant coefficient of the first variable of the second equation, because this is second row, first column. Okay. So multiplying, what will happen if you multiply that? So this will cancel out. So this will become the coefficient A21, X1, and then this one will just have what? A factor. A factor of A21 divided by A11. Multiply that factor up to the equivalent constant. Now, after that, let us go to the next. Then subtract that result from equation. So we multiply the equation 1 and subtract that result from equation 2. What will happen? So this is our equation 2. Take note, this is the original equation 2. Original equation 2. The original equation 1 will not change. This is the original equation 2. It will change because we subtract the result of step 1, okay, from equation 2. So let us subtract. You will notice A21 x1, A21 x1. So if you subtract, this will cancel out. This will become 0. So there is no coefficient, 0 coefficient for variable x1. However, for variable x2, that is A22 minus A21, A12 divided by A11. A21, A12 divided by A11. Okay, so this is the one. And so on up to the last coefficient, which is this one, A2n minus A21, A1n divided by A11. So take note of the format. Okay, A22 minus this one. The denominator is always A11. Okay, so A21, 1n. A21, 1, 2. Okay, so up to the equivalent constant of the equation. And if you you can see this is just a coefficient. These are just a coefficient, and also this is the equivalent constant value. So this symbolically will just equal to this one. This is just equal to this one without the variable x1, because variable x1 is multiplied by 0. That's why it was not represented here. Okay. So actually, okay, so the format is like this. Okay, format is like this. Okay. So there is a what? There is a error in here. If you simplify this, it will not go this one. But they only do not derive anything. Just take my explanation for it. This one, if you simplify, it will compose of constant times x2, another constant times x3, another constant times x4, and so on up to another constant times xn is equal to another constant. The concept is constant times variable, constant times variable. If you will notice, there is no first term because the first term is x1, which is multiplied by 0. Okay, so that is the only purpose of it. Do not try to simplify this one to this one because that is wrong. This PowerPoint is wrong. So do not simplify. Do not simplify. It is just used to tell you the format. Okay. So you have to do that procedure up to the last equation. You have to do the same procedure repeatedly. So for the third, we are now going to consider the next equation, which is the third one. Now, what will you do? Manipulate equation 2. Equation 2 is now the present equation 2, not the old equation 2. Okay? You have to manipulate the present equation 2, not the old equation 2. Okay? Why? Because we want equation 2, the present one, because there is no coefficient or 0 coefficient times x1. We want that. Okay, we want that. Okay, so repeat this procedure for the remaining equation to reduce the simplification. So the rest of the equation, we will what? Eliminate x1. We'll eliminate x1 because we don't actually eliminate x1 technically, but we manipulate the equation in such a way that the coefficient of the first term will all equal to 0. That is what we are going to do. All of the equation. We want all of the equation from the second equation, third, fourth, and so on. The first term, we want all of those constant coefficient to be 0 by doing the same thing, that process. Okay, and afterwards, that is the end of the step 1. So step 2, repeat the same procedure for the third term of equation 3. So we are now working on the third term. So we want what? We want to make all of the coefficient of the x2 to be 0. That's why from the third equation up to the last, we will force it to become 0. Here, all of this. Now, this is the correct write-up. A22 prime, because as you can see here, we have a prime. Aha, I was not able to, there is a prime. That's why A22 is not equal to A22 because this is not A22 because this is a prime. So all of this under or inside the parentheses is equal to A22 prime. And all of this inside the parentheses A2n prime. So we put the prime in order for this to be represented by simple letter rather than writing this all up. It's too strenuous. Okay. So now when we are going to work for the third equation, forcing all of the coefficient of the second term to be 0, now it will become double prime. It will become double prime. A33 double prime, A3 and double prime, and B3 double prime. So that is step 2. And repeat this process. Okay. So at the end of n-1 forward elimination, this is for, that's why we are actually eliminating one variable at a time. Variable at a time. Step by step, we are eliminating. Okay? Until the equation will look like this. Only one variable will be left here, multiplied by the what? The constant coefficient a n n-1 prime is equal to bn to the n-1 prime. So it looks like a triangle. Okay, the simultaneous equation looks like a triangle, and then therefore we need what? n-1 steps, and if you put that inside a matrix form, it looks like this. It will just look like this. So x1, x2, x3 to xn, b1, b2 prime, b3 double prime, b4 triple prime, and so on. And then also this one. So this is the result of our first phase, which is forward elimination. And then to complete the process, we have to solve its equation starting from the last equation. So we have now to solve. So, but let us start from the last one, this one. Because here, it is already a solved equation. Here, it's very easy to solve this because 0.7x3 is equal to 0.735. So therefore, we can easily solve x3 by dividing it by 0.7. Dividing it by 0.7, very easy. Okay? So, if you want to do the solution of this, the second phase should be backward substitution. So since we already know we can solve the value of variable x3, we can use this value to find the value of variable x2. And after which, we know value of x2 and x3, we can use these two values to find the values. That's why it is going backward, going up. Okay, the elimination process is going down, but the substitution is going up. Okay, so backward substitution. So as you can see, this is the last equation. We can easily solve for xn. Divide both sides by a and n to the n minus 1 prime. So, therefore, xn is equal to bn to the n minus 1 prime divided by a and n to the n minus 1 prime. So that is the value of xn. And then, so the next equation up. The next up equation. Okay, so start with the last equation because it has only one unknown. We can easily solve. And then, because we already solved this one, let us solve the rest going backwards. Okay, so this is the same way, but this is in terms of equation. It is very scary looking equation, but actually this is just very simple equation. It's just a matter of interpreting all of these mathematical symbols. Okay, so for example, if you are going to solve for x n minus 1, okay, you have to put it n minus 1. I is equal to n minus 1. Okay, so just like this. For I is equal to n minus 1, n minus 2, n minus 3, up to 1, going back to 1. Okay, so n minus 1 is equal to I. So n minus 1, therefore n minus 2. Okay, n minus 2 prime, n minus 2 prime, n minus 2 prime. Okay, so this is what? N minus 1. So n minus 1, n. So and so on, going down. So n minus 1, n. Okay, so it is successively represented here. So all of the coefficient of the variables will become negative because it will transpose to the other side of the equation. Okay, and all divided by a n minus 1 to the power n minus 2 prime. Okay, this is how we try to make this equation compact here. The same equation here. Okay, this one is equal to this one. All the rest of this is equal to this one, and denominator is equal to this one. Same. For I is equal to n minus 1 up to 1, going backwards. Okay. So that means that is the two-step procedure for solving the simultaneous linear equation by using Gaussian method, or the name Gaussian method, or the basic Gaussian method. Okay. So this is Dr. AP, teaching engineering for nation building.